Welcome everybody. My name is Özgü. I'm a senior research scientist at Simula Research Laboratory in Oslo, Norway. I also teach in University of Oslo, so I'm also an associate professor there. Today what I will talk about is mobile measurements and try to introduce you a relatively young platform, MONROE, and try to basically walk you through how you can basically run experiments in operational networks. So the way I would like to run this is basically, it will be more about the system design, how we build things, what was our experience, what you should expect to see. So more on kind of the description and the experience part of building the platform. Of course, we didn't reinvent the wheel again, but there are some unique parts that you need to consider when you are doing mobile measurements. You have, for example, subscriptions, mobile subscriptions, you have data quotas. You cannot really let people have root access because if they basically do something wrong, you might just lose your node, and it's very expensive to lose a node. So that's why there are some tweaks we need to do when we are designing and implementing the system. So I will just basically describe these. And of course, it's all about measurements. This is also all about measurements, the PhD school. Then I will try to give you a sense of what are the different things you can run on this platform. Give you a couple of examples based on what we have done so far, and try to give you more pointers than results. And we will try to kind of do a live demo towards the end of this session. And in the lab part, we will ask you to have a couple of maybe 5-10 groups, like people, 3-4 people in each group. And we will ask you to actively use the platform. You will be able to run an experiment. We just choose web as a use case. So everybody will run web experiments on multiple operators on the selected nodes. And after that, we would like to kind of combine all the data and ask you to do a very simple benchmark of how is the operator performance, how is maybe web is in this operator on another operator. Just kind of a little bit play with the platform and have a little bit benchmarking experience in a very small scale. So that is basically the plan for today. Okay? So, shall we kick it off? Yes. Okay, let's start with some motivation. Why we are even considering mobile. So mobile networks are underpinning a lot of vital operations. So you basically use it in health systems, ambulances use it all the time to communicate with the doctors. Of course, everybody has multiple devices that are connected to the mobile networks. And they are using fleet management systems to have a view of what are the different, basically, what's the status of different the vehicles, and they are also used a lot in security-related things. And with 5G coming up, the use cases will also increase, because then it will be a divergence of different applications. You talk about IoT. There are different aspects you can consider in terms of security and so on and so forth. But it is everywhere, and it is basically maybe one of the most complex infrastructure one built throughout the years. And we have much more powerful devices. We have now 3G, 4G technologies that support a lot of different applications due to the increase in high data rates. And I just put a couple of fun pictures just to illustrate. It is basically very crucial to understand how these mobile networks work in order to move forward in terms of how we can advance it. Okay. I also would like to a little bit describe why we are interested in terms of the infrastructure. For example, we started with the 2G systems. We have the GSM, GPRS, edge networks. On top of it, we built the 3G networks, and now we are building the LTE networks. And we have also the micro, pico, all these different cells coming in together. And especially if you consider mobility, you are basically traversing all these different networks when you are doing mobile measurement analysis. And this makes the whole system much more complex and dynamic. On top of this, you basically have a lot of different applications running on top of them, which might have different requirements, which might basically have different necessities that you need to meet. And on top of this, we have our user experience, in a sense, quality of experience you need to consider. And if you also basically consider this picture as a whole, then it becomes very complex because you need to consider it in different layers. It's the infrastructure layer, it is operators, how they deploy their systems, how they configure their systems, and theory usually doesn't tell it all because you can do different things and it might, you need to consider different configurations and so on and so forth. And it's also very hard to isolate different layers. You have the physical layer, you have the layer 3 and 4, and you have the applications, and again, you have the quality of experience. So that is basically our motivation to try to have some objective end-to-end measurements to try to understand, first of all, the current mobile ecosystem. And this is, you can also take it from different perspectives to basically say, if you develop a new application and service, will it work in current systems? What you need to tweak in order it to work? Or more importantly for protocols, there is one big issue that can you deploy it in internet? And mobile networks are known to be a heaven for middle boxes. So if you are working in that field, it's very important to see if you develop something, whether it will be there, it will be even kind of usable. So that is basically where we are coming from and our main motivation. Can we basically try to understand the mobile ecosystem in order to basically see whether we develop something new will work in the current operational networks. Also try to understand and identify and have a realistic and meaningful benchmarking of different operators. So to achieve this, we designed MONROE. It's a distributed platform. It's a hardware-based platform. What it is basically you basically take these nodes, hardware, small programmable computers, and distribute it over different countries. And then you basically, it's flexible. You can run different measurements on top of it because it's Linux-based machine basically. And then you can basically analyze these results and try to basically achieve the goal of what is the mobile ecosystem now and what can I do to improve it with innovative systems, services, and applications. Okay, so little bit of details. Where are we? We are currently in 4 countries. We have deployed around 150 nodes and counting. There is some interest to have multiple additional nodes in different countries like UK, Portugal, and Germany. So I hope in the upcoming months we will have more nodes in there. I think what is unique about MONROE is we also consider mobility, which is one of the most important and interesting aspects of mobile network. So in order to also understand the mobility and how it works in operational settings, we also put these nodes on buses and trains and try to basically monitor and run the same measurements on the buses and trains under mobility scenarios. On each node, we support multi-homing, so we have 3 operators, basically 3 different SIM cards that belongs to different operators, and we also have Wi-Fi. So you basically have 4 interfaces. You can run experiments more or less simultaneously, and this basically allows you to compare different operators under the same conditions because the box is in the same place, and if you run the experiment more or less in the same time, the conditions are in a sense very controlled, apart from the variety of the operational network. So you can basically compare these different technologies, 3G, 4G, and Wi-Fi, as well as you can basically explore different ways of how to put them together. MPTCP become very popular. You can try to run MPTCP on it. You can try to basically define your own protocol or algorithm, try to basically do the handover. So you can basically try different things due to the multi-homing feature of it. So, I will now go a little bit, I will try to describe a little bit the system design. As I say, we are not reinventing the wheel again, but we have different constraints that we need to consider when designing the system. In general, basically, of course, we have a user access and scheduling system, and this is required, and it's by design. We did not want to give SSH access to users for them to just reserve some resources and go and do their experiments and come back. And it was because, again, we don't want them to maybe do something by mistake and then at the end break something, a node in a bus that takes a lot of effort to recover. So we basically also try to make it simple. So you basically design your experiment, and through the user access and scheduling system, you just deploy it in a large number of nodes. Because if you just give SSH access, I mean, you can do scripting and so on and so forth, of course, but you just basically, with one click of a button, you can deploy the same experiment in tens of nodes. And that is basically the simplicity of having such a platform. It has a scheduling. The scheduling aspect is coming mainly from, we do not want to allow multiple people running different experiments on the same node at the same time. We try to basically eliminate the bias, because if somebody else running an experiment and you don't know, it will just generate background traffic, and then your results will not reflect the reality. That's why. So in the core of it, of course, we have the MONROE node. This is basically the hardware we we basically built. And as I said, it just basically connects to 3 operators and the Wi-Fi, so it just allows experimentation in commercial networks. And of course, when you run an experiment, you would like to get the results of experiments in the results back to you. So we of course have kind of a backend system that serves this purpose. I mean, I will try to give a lot of details and a little bit experience, but I just want to refer to experience paper we have in Mobicom that will be out soon. If you are more interested, if you are interested in more details of the system. Okay, so what is a MONROE node? As I say, it's a small programmable computer, and among different choices, we ended up using the PC Engine's APU to basically serve as our main board, which is a quad-core processor. It has a reasonable RAM and HDD, and it just allows us to do most of the, even the demanding applications like web and video. So when we first started, the modem that was available on the market, that is the latest, that supports the latest technology, was a MiFi. MiFi, I don't know, maybe some of you use it. It's a kind of a small router with batteries. You just put your SIM card in, and then it just serves as a entry point to operational networks. And that was basically our initial design. So here you can basically see the APU board. We have a USB hub to accommodate 3 of these MiFis. And then you have the Wi-Fi, you have the SATA, and we have a GPS and some antennas. So that was basically the initial design of the node. What has happened? We have some adventures there. So APUs were quite stable. However, it was hard to say the same thing for MiFis. So we have a couple of instances. We have an instance where basically they have a firmware upgrade that swipes away all the settings and all the configuration and all the passwords, that we lost access to the nodes. It was like shut down. We work with them, we try to accommodate the new configuration and updates and so on and so forth, but it was really not a good experience. And they were also prone to a little bit, they were popping up in a wrong state and so on and so forth. So there were also some instabilities. And maybe part of it is basically they are not designed to have it, to be used in our use case. But the most scary one was after using them for 5-6 months, they started to get fat. They just started to have bloated batteries. They got bigger and bigger and bigger. And as you can imagine, it was so scary in a sense because these devices are on buses and trains. Can you imagine if some instance happens and, I mean, God's sake, didn't happen. We are very happy about that. And like the Samsung event, an explosion of battery. So, I mean, at the end of the day, we were like, this will not work and we need to move on. Luckily, at the time of these things happening, there were available new modems, new technology that we could basically go through a transition. And of course, our priority was no batteries. And we also kind of know APUs were very stable. So we want to go basically with what we call a dual APU route. So each APU can have 2 slots. So what you can do is basically you can have 2 mobile operators in here and 1 mobile and 1 Wi-Fi here. So if you basically put these 2 boxes together, it will just basically meet our requirements. You have 3 mobile operators and a Wi-Fi, and they are in the same area, and you don't have batteries. So that was basically at the end our final node design, which has been deployed for the last couple of months. They are on the trains, they are on the buses, and it is working nicely. And of course, always you want to see the positive in it, but there was a really positive in it. By changing this modem or by going through this transition, we were also able to update the modem category. So it means we have a newer version of modems that supports, for example, if you are familiar with it, carrier aggregation in mobile networks. So they can support higher data rates and they can support different, they have different properties. That's basically the newest technology that is available on the market now. Okay, so that was about the hardware, and hardware is of course one part of it, but I think it's more important and critical to basically talk about the software we are running on top of the system. Because this is basically, the software is the brain of the node. It just basically need to make it up and running all the time so that if we need something, if we need to update something, we have access. That is the most important and crucial thing, because you can always change the software if you have access to the node, right? And that was basically our priority. Can we just keep these nodes up and alive and accessible? And if we need something, we can just basically go back and update the software. So in order to do that, we basically have some management components that are running on the node. We have also some maintenance components, like some watchdogs try to figure out if something goes wrong, what has happened, can I fix it, and if I cannot fix it, I need to put it in a maintenance mode so that an engineer can check what has happened. And we also design a boot OS, which basically, if there's a file corruption, for example, it's really not easy to basically recover it. Then what we do in that case is we basically reinstall the system to avoid all the problems we have experienced, and you just basically have a pretty fresh installation that is hopefully in most of the cases free of the errors you experienced before. So that is basically the maintenance and the management part. One part is basically we are running everything in a virtualized environment. And this is for us to basically a little bit have a separation between what we are running to kind of make sure that the node is up and running, as well as what the experiments are allowed to do in a sense. So we choose the Docker as our lightweight virtualization, lightweight virtualized environment, and you are here. So you are the experimenters. So you basically design an experiment, put it in a Docker container, Then when you have your container, you put it on a node, run your experiment, get your results back, and you are done. So it is, we will basically illustrate how the process is, but it is really easy if you have a starting point, entry point, in terms of how you can build on top of it. But that's basically the main idea. So as I say, you are here, you will just design your experiment. But in order to help you, we also have different components on the node to get different information. For example, we run some basic experiments to like pings, some bandwidth tests, some trace routes in order to collect long-term measurements. We run T-stat. I don't know, maybe some of you are familiar. That's basically a passive traffic analysis tool. So everything happening on the node, we have some information about like flow level, the TCP level, IP level information that is collected. But more importantly, I think we have the metadata. And when I say metadata, it is maybe more important in the context of mobile. Because if you think about the mobile, you need to know the cell ID, which base station you are connected, what is the signal strength you are connected to the base station, what is basically your channel conditions. You can get a lot of context information from the metadata. Of course, you need to GPS in order to basically process the data. So this information is basically, we get this information from the modems, and we broadcast this information to the users. So you will basically have, from here, you will get into your container. You can get all this information. And this is very important, especially when you are analyzing your results. We also have an internal NUT function, again, to kind of little bit isolate what we have and what we expose to the users. But kind of the overall main idea is we need these nodes up and running. We cannot allow users to change something, to break something, so that we lose access to the nodes. And we also want to make it lightweight and easy in terms of to run a large-scale measurement in multiple nodes. So that is basically what I want you to take away from here, up until from here. Okay. So a little bit more about maybe Docker virtualization. As I say, each experiment runs in a virtualized environment in the Docker container. Docker containers are based on a layered system. So what we have is basically on each node we have a base image. So this includes all the very common packages, like if you want to use C, Python, whatever you want to use, most of those libraries are there. So when you design your experiment, you don't need to load all of these packages because it's there. You just want to use your code and maybe additional library that you want to build. So it's basically a layering system. So you just basically put your layer, and that is basically what you need to design. And basically you have access to the network interfaces. You can write, read from your file system, and if you want your results to be transferred, you just need to put it in a defined results repository so that we can synchronize it to the backend and provide it to you. Of course, you can just run SCP or some other commands inside your container and send it directly to your preferred location. That is also possible. And if you really want to talk a little bit about the backend, as I say, it is basically, it has a management and maintenance related backend system. So we basically need to monitor all the nodes, and when they have some issues we need to attend, we try to solve it remotely first. If we cannot solve it, maybe we need to attempt to change the node. So we need to carry out some management and maintenance activities. We have the user access and scheduling, which I will describe next. We have some measurement responders. This basically means you are running, for example, a speed test. You need to run it towards something. So we also provide some servers that you can run ping to, or you can run some measurements towards these servers. In general, basically, once you schedule your experiment in a node, what happens is basically your experiments are run here. when you have the results are synchronized with a remote repository. So it just from here synchronized to a remote repository. You are here basically as an external user, and then it moves into a user storage and feedback into the user access so that you can just download the information from there. And for all the metadata or the experiments we run frequently, we just basically get it into a MONROE server, and then we import it into what we call a MONROE database. What it does is basically, there's an importer function that gets all the data we collect and provides it as open access to the users of the platform. And we also have a visualization system that shows near real time, I would say, what is basically the RTT running on the node. If you have some speed measurements, how does it look in time? Where is the node in terms of GPS, if it's a mobile node? And it basically shows what are the interfaces available there, and so on and so forth. So currently it is more kind of a monitoring system, but you can also use it more of a kind of visualization of different operators, different operator performances. Okay. In terms of user access, I would say when we started this project, it was one of the FIRE projects. So it is Future Internet Research Experimentation, I believe. I should know that. That's why they wanted to have, to kind of, not force us, but they encourage us to have a federation. So in order to provide this, we basically go to the route of providing the first initial access in terms of certificates in a federated system. So we basically just, if you want to use this system, you need to go to this iMinds, that is basically the body that provides these certificates. And when you get a certificate, there are many testbeds in the FIRE community. There are wireless testbeds, there are smart city testbeds, there are IoT testbeds. So when you have this entry point, you can use any of the testbed in the FIRE catalog. So that was kind of a nice entry point. But of course, each testbed have different requirements, but that is basically how you get your certificate. Once you get your certificate, you have to be approved by your project that you want to use. In this case, it will be us. And just for today, so that you don't really need to go through all these steps, we basically signed some certificates for you, just skipping this process of having the FED4FIRE certificate. But if you really want to be one of our users in the future, you can really follow this process. Just talk to me or some of the people I have in the room that are MONROE people, and we will try to see basically how we can get access and so on and so forth. Just a note there, currently the platform is not open, and you will be one of the, maybe many, but one of the first users that has access. And we are planning to make the platform open after summer, so that people just can come in and use. We, I think, have around 30-40 different institutes using the platform currently. Some of them industry, some of them SMEs, and some of them researchers, just like yourself. So that is basically kind of the number of users of the platform now, and I hope it will grow after we make it open, and hopefully there will be some of the users from this room. Okay. So that is basically how you get your first certificate, and then here comes the interface. As I was telling you, we are trying to make it easy and simple. So in that sense, what we provide in the web interface is you have the resources. What does that mean? You basically have all the different countries, Norway trains, that's basically the nodes on the trains, Sweden and the nodes on the buses, and so on and so forth. And you have different node types that I will come back to, I can mention later on. And we have the different models because of this, due to this transition. So APU1 is the older version, and APU2 is this dual APU system, more or less. And what you see is basically, if you basically select one of the countries or one of the sites, what you see is you just see a list of the nodes. I just wanted to show one example. And whether it is active, what is the type of the node, where it is, and you can basically see it on the map. Wherever it is deployed, you get the address. You can link into the visualization tool to see how does the ping look and what are the interfaces you have there. And you also see what are the different interfaces you have. You have, for example, Telia, Telenor, and other operators you can have. It's just an example. So if you basically check this one, and if you see this active status with a thumbs up, that means you can just go and deploy an experiment on this node. Of course, it's sometimes very difficult because you have kind of a long list, but most of the time you know where you want to run an experiment. And if you just want to run experiment, just give me some nodes, you can do that as well. So this is the resources tab that you will probably also see when you access the platform. And then what you do is basically you have the new experiment tab. What you need here is you give a nice fancy name to your experiment. You need to basically have the script, which is basically your container in a Docker hub or in our servers, that you just say, okay, I want to run this specific experiment. In our case, it will be web, for example. And then if there are any parameters, you just need to define your parameters. So today what we will do is, I want to do web. Great, I will pull the web container, and I will ask you to define a website. I don't know, what's the most popular website in Ireland? So, or you just say BBC, CNN, YouTube, whatever you want. You just define the website, and it just basically try to evaluate the performance of that web. You can basically select the number of nodes you want to use. You need to define a duration of your experiment. You just cannot basically say, I want to run an experiment one day. It doesn't make sense. Maybe your experiment is short. Maybe you need a little bit more time. You need to define it. After that period, your experiment will be cut. You will not provide any access to the interfaces, which is important in terms of scheduling. And you can either explicitly specify the node IDs, or you basically let the scheduler find the most appropriate node that you like among some of the filters. It might be a country, it might be different things. We have some filters that you just say, I don't care which node you give me a node in Norway. The scheduler will just accommodate that wish. What happens next? You basically just hit the submit button. You just select your nodes, you select all your parameters and experiment. And then we go into the process of experiment execution. And once you have basically all the results, you will basically go to the status tab, where you will basically see what is the experiment name. I call it web trial Docker. Apparently I run it on Saturday, so you basically then see if it is finished, and here maybe the most important thing, when it started, when it stopped, this is the duration, and here is your results. You run your experiment, you just click here, get your results, and then you are done. Okay? Again, you might do it a little bit differently, but we found out that this is kind of a nice way of doing it. We also provide some APIs, so if you don't want to run it over the interface, scheduling or web interface, you can just write your script, you can communicate to the scheduler, and you can basically apply the same filters, you can ask for the same nodes, and you can basically say, I want this node, give me the slot for this, and I just want to run my experiment. But the overall architecture and the way you can do things is like this. Okay? Any questions so far? Little bit more details about the scheduling. It basically what it does is on the nodes it deploys, start, stop the containers. It's all about containers. So we report the status and the resource usage, and I think most importantly it does the accounting for us. In other testbeds, you may not need accounting, but we desperately need accounting. We cannot just go over the data kudos allowed, otherwise we will be throttled. And we also need to provide a user kind of good sense of if they deploy an experiment. Will it fail due to the throttling or some other reason? So I think the most important job of scheduling is, of course, one, make sure that different experimenters are not accessing the same node at the same time. Two, do the accounting for me, so I know I can watch what I have used, what is left, and how can I do things maybe a little differently. And in terms of the policies, as I say, it's basically everybody has a certain data quota. You don't have unlimited data quota, so that you can schedule experiments for the whole month on all nodes. It's not, of course, happening. So you have a certain data quota that you basically can use, and it is resetted every month in the beginning of the month. And other than that, it is first come, first serve. So since you have a certain data quota, we just make sure that you cannot just consume all the data quotas available we have. And then if you have a special need, we take it case by case. Yeah. So little bit details about how we do the data and metadata import, maybe not very critical, but we have all the information on the node, and as I say, we put it in the repository, and we have an importer that puts it into database. The things we can consider here is we are running rsync. That means there is a little bit kind of periods that we do this synchronization, which we cannot do it all the time. And so if you just do this experiment, you just need to wait a little bit, and in most of the cases it's 2 minutes that the files are synchronized. And finally, we have a database which you can get a copy of it, at least our users at this point, which have all the measurements we run as a platform, like RTTs, pings, and some HTTP experiments, and all the metadata that might be relevant to your experiment. And I think it also provides kind of a benefit. If you just run an experiment and did not collect the metadata during your experiment, you can just go back, match the timestamps, and you can get all the additional information you need without using your data quota. Remember, everything you do costs you from your data quota. So you need to be very wise in terms of how you want to use it. So if you don't need to send any additional information, don't send it. If you need it, definitely. But just need to be a little bit kind of careful and cautious how you use it. Okay? Okay. So about the experimentation process, the way we design it is we don't want you just to go and have a large-scale measurement first, of course. So what we ask you to do is you design your experiment. In the lab, we will give you a design experiment to just speed up the things. You basically configure all the configure the container for experiments, and you need to put your container in a Docker hub or in a server vhost. And you just need to schedule a container in a testing node. Testing nodes are nodes that are sitting in our labs. They still have the mobile communication, but if something happens, at least we have access to them and we can fix that. So that is basically the testing phase. You just basically need to test it. You just see everything is working. You do the updates to your system. You change the things, the parameters, whatever you want to collect. And then you just say, I'm ready. Give me my certificate. Certificate means I approve that everything is working and I want to go large scale. Once we are there, then you can basically run the experiment in a larger number of deployed nodes, which are on buses, trains, or in different hosts. It might be in schools, it might be we have some on train stations and different places. So this we found to be useful and required, so that again, we don't want anyone to kind of break the connection to the node. That is like utmost important thing and one of our priorities. Okay, so that was all about the design, a little bit of our experience, and what are the different components you expect to see in such a platform design. And I would like to a little bit talk about measurements and experiments. Any questions so far? Nothing? Okay. So let's try to see what you can do with such a platform. I'm sure you can imagine what are the things you can do, but I just want to give some examples to maybe initiate the discussion, and I will be happy throughout these days to kind of discuss more what you are interested to do and whether we can accommodate it, and maybe even what we need to do to accommodate this. So I will be very happy to discuss this. Maybe before going that, I can also introduce my MONROE people here, so if you cannot see or find me, you can talk to them. Stefan from Karlstad University, he will do the demo and he will be with us throughout the day. Where are you, Miguel?
Was in the back before.
Okay, probably he will be back. For Marco, you will be around maybe to answer some questions or have some discussions. And there are a couple of people who has used MONROE, and you can also talk to them. Anika there, Kostas there, so you can basically try to discuss with them a little bit. But yes, come to us. Okay, so MONROE measurements and experiments. So in terms of kind of, like we call it stakeholders, who are the users of MONROE, who want to do something on MONROE? So, and who are we kind of targeting? And it also shapes in terms of what type of applications and measurements you want to run, right? So basically, let's start with the operators. Operators, of course, can benefit from MONROE because they have the view from the end user's perspective, right? Because we mimic a real user. I mean, we have the box, we have the subscription, but they don't usually have this view. They usually, what they have is they do dry runs with their equipment, where they basically try to collect some data in a shorter period of time, or they use the information that they get from their network side, which means still, they don't have what the user sees, they have what their network side sees. So in that sense, we have been working with different operators, and in fact, it has been very fruitful collaboration with them. We identify some of the issues they have, and they try to fix it. So it was very nice discussions, and I think at the end, we come to kind of a certain place that when we say something, they kind of believe, and they try to go and do something about it. In terms of regulators, of course, regulators are very interested because they want to force the operators to fulfill their requirements in terms of what they say and what they deliver. So we have a lot of discussions with the regulators and the regulator body in Europe, BEREC, to basically just say, okay, we observe this and they want to get our data to try to see what they kind of give them is the reality, even we have a kind of a smaller data set. And they also want to compare it with, most of the regulators in Europe are running some crowdsourced type of apps to, for example, get the RTT and bandwidth, and they just also want to compare it. One of our advantages is, of course, we can run a long-term measurement. In crowd, you just basically have a one-time measurement maybe, and it is on user's own will. But for us, you can have access to the platform for a longer time. You can repeat the experiments. You can basically do something in different frequencies, and that is very interesting for regulators. So we then have businesses, for example, everybody who depend on mobile networks, like the ambulance services, or I don't know, probably the trains don't have it here, but in Norway and in other countries, they provide Wi-Fi service over mobile networks. So they are very interested to understand how is the mobile network and how they can basically manage, they can even provide a reasonable Wi-Fi quality on the trains or buses. So we work with them. One of the interesting things for them is basically try to understand which operator provides the best coverage in their routes, so that they can negotiate with them. Even one operator is slightly bad, they can maybe get a good deal. And this basically had happened. So, so from their perspective, they're interested in understanding and also comparing the performance from maybe a little bit also business perspective. Of course, users want to basically see who is performing better, or maybe most importantly, if I'm a kind of a user of certain applications, which operator supports my application the best. Researchers, we are all interested in understanding and advancing the mobile technology, so I think it's obvious that we are in the middle of this. So in terms of different use cases I will talk today, we have the mobile broadband metrics, which means the basic QoS related metrics and coverage related metrics we will try to understand and evaluate. We have the applications, whatever application you want to consider, I will give some examples. And we have the protocols, so you can also test different protocols, the support of it, or if you change a protocol, what will be the performance improvement, so more on the algorithm side. So that will be basically three main use cases. A little bit about each use case, and I will go more into the details. So for the mobile broadband metrics, we are talking about network tomography, like how the mobile ecosystem looks like, and traffic analysis. For the application, we are mostly considering video and web. Of course, there are new applications that might emerge, and we will be happy to accommodate that. But most of the traffic, assuming is video and web, I think we are covering most of it, really. And then it's the protocol innovation, whether the internet path supports a certain protocol, which is much more difficult in mobile due to the middle boxes and all the different things the operators basically deploy. We are interested in multipath protocols due to the multi-homing. It is one of the advantages, so we can do that. And since we have Wi-Fi and mobile, we can also maybe do something on the traffic offloading. Okay, so I think I kind of covered this part, and maybe I can just give some examples and try to discuss a little bit over the examples. So one thing we were trying to do is basically we were trying to build some coverage maps, and we were trying to do it in a reliable and efficient way. What MONROE provides is basically this. So here you just basically see an area, and the time is in this axis. So you basically have a run, this is a bus route, and then you have another round on the second one, and then the third one and the fourth one. So you can just build this. This can be in terms of each route can be maybe traversed multiple times a day or over multiple days. So you can basically just go over the same route over and over again. When I say reliable, what I mean is basically you need to, if you just go through one route just once, how reliable it is for you to say there is 3G, 4G or no coverage in this area. You just go through it just once, maybe you got unlucky or you got lucky or something has happened, it was congestion, it was something, right? So with reliability, what we mean is basically you need to traverse these routes multiple times and try to understand it from the user's perspective. If I go from my home to my office every day, one day maybe I have good experience, maybe one day I have bad experience. But if I aggregate this data and try to basically say what I see on average in terms of coverage or application performance, that is what we are going for. If you do have the repeatability, then you can say something more with more confidence in a sense, right? So this is basically what we did. We applied some techniques to try to profile the coverage, and then we marked the red as good coverage areas, mostly 3G, 4G, and green is the good coverage, red is the bad coverage. And then we basically try to build it for two different operators in Norway just to illustrate. There are some similarities, but there are also some differences. And again, if you are interested a little bit more on this, I just put a couple of publications we have there. We were here last year to get the best paper award that we are extremely happy about. Okay. So we also have some results in terms of the traffic analysis. What we did is basically we ran the TSTAT, the traffic monitoring tool on MONROE, but we wanted to understand whether there are any proxies in mobile networks and how they behave. and whether there are any performance enhancing proxies, the PEPs, in the networks. And the picture looks quite interesting and quite different. What we figure out is basically all of the operators we test, which is like 11, 12, they have the L4 mangling, but some of them, they don't do the performance enhancing in a sense that how we can check it, we have the server-side information, we have the client-side information, and we try to see the mismatch in terms of kind of the good. By checking that, we realize there are some who don't do that on port 80, but more interesting and maybe surprising, or it just shows the complexity, some of them do it sometimes. So the dynamicity of the mobile network, it is in the same place, I measure it in time. Sometimes I hit that, they do the PEP, sometimes I don't. So that was one of the interesting results we found out, which is summarized in this paper again if you are interested more in the details. But it basically again shows the variation and the complexity of mobile networks. I will be very surprised if you see such a behavior in broadband. But here, maybe there was an event, then you just go to another base station, which has maybe a little bit different configuration. Even me working in this area for a couple of years now, more, I cannot make really sense out of these results. But it is how you basically experience from the end user perspective. Okay? Okay, when you come to the application performance, I would like to show some initial results on two of the focus applications, web and video. Let's start with web performance. So we have a container that you will also use in the lab today. That is basically based on Firefox Selenium to kind of capture and download a website. And we try to basically run an initial analysis of how does the different operator look, do we see differences, and as well as how is the different protocols look. Do I see differences in H1, H1S, and H2? There was many papers over the years on this with not a clear conclusion. So we just wanted to provide a larger controlled environment, large-scale controlled environment to kind of rethink or kind of to see again how does it look like. So just one example in terms of a website, Instagram here, you have the different operators. I mean, I would say most of the operators are quite equal in terms of performance, with some variations, especially on the southern part. I would say northern part is more consistent, and you can see a lot of variations in the southern part. You also have the H1S and H2 for Instagram, and it is also not very kind of easy to see a trend. Here, for example, even the median is lower. Yeah, maybe here the H2 is performing a little bit better. But if you look at into the kind of different websites, that was just one example with Instagram. If you have a look 10 websites, for example, the picture is maybe a little bit different. So if you try to see the H1 and H2 difference over different operators over multiple websites, just to kind of have a feeling of how does web work, then you basically see maybe it is slightly lower, but it's really not that different. So in terms of the performance enhancement in H2, maybe we are not there yet. Okay, I will go to the video streaming. We have done some streaming measurements with Dash. That's kind of the de facto video on demand streaming tool, I would say. So we have developed a Dash measurement tool, and we basically try to do like this simple exercise. I have many different rate adaptation in Dash. That is basically one of the most important things you can you need to understand and implement in Dash. And then we also have multiple operators. How does the ecosystem look like? This was a small scale experiment. So we have the basic, which is a throughput-based rate adaptation, and we have the Netflix buffer-based rate adaptation, and then we have the hybrid, which is segment-aware rate adaptation, the SARA one. So we basically evaluated it using, of course you can do with PSNR, SSIM, and if there are any video people here, we wanted to do more kind of perceptual video quality assessment. So this is a tool called Open Perceptual Video Quality Assessment Tool, which gives basically how you perceive it. It's an open version of a standardized perceptual video quality tool. So what we observe is basically different operators really maybe don't have so much differences. In some places, yes. But what was interesting is Netflix was the one that performed the worst. Of course, I need to talk a little bit about the experiment setup here. Here we use the videos of like 5-6 minutes. We didn't have like Netflix video streaming of hours. And what we observe is basically Netflix is a little bit conservative in order to how they do the rate adaptation. And maybe if you have 1 hour of video, they can adapt and maybe provide overall a better rate adaptation. But in a shorter scale, like 5-6 minutes, it was really difficult to for them to kind of reach out, and on average, they were always a little bit worse. And maybe for shorter videos, you really need a little bit different algorithm. And we are very interested to test how YouTube does it, because the YouTube is more working towards shorter videos on mobile. So that is the one missing part. Hopefully we can complete soon. And in terms of operators, interestingly, we did not see and observe much difference. That is because the operator data rates today is well over what you have an HD video stream. So you can think about maybe 5 megabit per second of a video, dash video on a mobile phone with your screen. But the operators can support 80, 90, 100 megabit per second. So in that sense, it's really hard to see any operator difference, at least for this was done in Norway. For the operators in Norway, that was not the issue. Okay. Okay, I will try to wrap up with some examples on the novel services and protocols. We designed a tool or extended tool that's called PetSpider. If you are in that community, maybe you are aware of it, which basically measures the pet support. And we run some measurement campaigns to see whether we have MPTCP support, whether we have ECN support, and so on and so forth. The description of the tools and the initial results are here for people who are interested in it. And there are some papers under submission. Hopefully we can share it later on. And I just also wanted to mention MPTCP as my final slide there. We have done a lot of measurements in MPTCP for the last 3-4 years. This is one of the last things we have done, implementing an intelligent interface selection algorithm for MPTCP. For those people who are familiar with MPTCP, you know the initial path you start the connection might impact the results quite significantly. So if you are able to read the metadata from MONROE, you can maybe have a better estimate of which path you should use first, so that you don't go into that penalty of performance. So, for example, if you have a VLAN and LTE, if you just open it in the VLAN, or if you open it in LTE, so you just see kind of a different relative download times. And here, if you just open it in, if you open it, so this is VLAN and LTE, and this is LTE and VLAN, and you try to basically, if you have to do the intelligence, you are always close to the best possible option. In this case, it might be different, of course, but you are always having the best option, depending on which interface you have it. Okay, but we have done a lot of work in terms of evaluating schedulers, kind of modifying the congestion control based on some shared bottleneck detection, new scheduling algorithms, and it's very powerful to show it works in real life, in real networks. And since now Apple is really backing MPTCP quite nicely, I think there will be a lot of interesting things that can be done, especially under mobility scenarios, to investigate different aspects of it. That will be it for me before we go into the kind of a demo session. Any questions I can get, maybe? Yes?
So you have MPTCP deployed on the MONROE nodes already?
Currently, it's difficult to run the MPTCP in a container, so we do it on kind of some development nodes running, but we are building a virtualized environment, just not a container, because in the container you cannot modify the kernel, but in a virtualized environment running on top of it, you can do that, and we are working on this, have initial steps towards that. So most of these one are done on stationary nodes, on the MONROE nodes, but maybe it will take a little bit more time to do it large scale in mobile scenarios, but hopefully we will soon be there. That was a little bit faster, yes?
I'm not very familiar with mobile measurement, but from my understanding, on the MONROE node, you have a set of predefined tools. Is that correct?
Yes.
Is there some flexibility? For example, can you write some script to...
Absolutely. So we provide set of tools for you to get as a template or to start with. They're open source. Maybe in Stefan's presentation you will find the links. But you basically are free to design anything you like. You just take it as an entry point or initial template. You modify it, or you just say, I know what I'm doing. I don't need these templates. I can write my own script and put it in a container and run in MONROE. You are free to do that. So it is the degree of freedom in that sense is as much as you like. You can do whatever you want in the constraints of the platform.
So you can use the initial tools as building blocks for...
Absolutely. Absolutely, absolutely. And as long as you understand what you are doing, you don't even have to do that. But it's a good starting point to understand how to basically access some metadata information, how to store your results, and to get a sense of what I'm doing and how should I proceed. Yes.
Is there a difference between mobile nodes and stationary nodes in terms of capability?
No. It's the same node. One of them is on a bus and one of them is in my office or in my home. The only difference might be maybe on a stationary node I have Ethernet, but it doesn't really matter. But they are exactly the same thing, and you do the things exactly the same way. Of course, in mobility you need to be a little bit lucky because maybe you can get out of coverage, you might get into a tunnel, so things are, I would say, more frustrating. But if you really kind of persistent, you can really get good, high quality stuff. So yes. Yes.
Is there support for IPv6 on the
We have an initial version of it. We did not push for it that hard because most of the operators don't support it. So for us, it did not make sense to have it in the platform where the operators don't support it. But we have a version that we can get into production, let me say, if or when the operators support it. Yes?
So you mentioned with your mobile route, the connection changes dependently. Sometimes it's good, sometimes it's bad in the same location. What follow-on research has been done? Has anyone looked at what causes those fluctuations? Is it different weather? Is it different network congestion?
It is usually the coverage. It's the deployment of the base stations of the operator. Because remember, these the trains or the buses traverse a large portion of each country where you might not have coverage. So I think majority of the thing is, especially in Norway, that I'm more familiar with the infrastructure. You have a lot of tunnels, and inside the tunnel, they are trying to put some base stations there, but we are not there. So when you go through a tunnel and if you are running an experiment, boom, you just lose the coverage. But if you are in the city center, the majority of the time, what impacts the mobile performance is you have definitely the time of day impact. So in rush hour, of course, there are many users, there is a lot of congestion and so on and so forth, and the performance drops. And in non-rush hours, it's a little bit different. So if you you can easily see it in the stationary nodes. It's harder to quantify it on the mobile nodes, but we are trying to correlate it so that we know the time of the day impact and whether you can basically try to get the same measurement with the timetable of the bus or train to kind of also maybe capture it. But I would say time of the day due to number of users and congestions, and mostly the deployment strategy of the operators in terms of base stations and where they support the transition from 2G to 3G. So the coverage aspects and the congestion aspect is the most difficult parts of this.
Thank you.
Yes?
There are questions. Can you repeat the question because of the mic?
Or speed loud, or I will try to repeat. Yeah, okay. Yes?
Okay, if I well understood, this MONROE, it's a framework that you can collect data.
Yes.
And these nodes, in particular nodes MONROE, you are embedded on vehicles, for instance. And my question is, when you collect data, can you say if the communication is between vehicles to vehicles or vehicles to infrastructure? Can you separate this kind of communication?
Okay, the question is, can we separate vehicle to vehicle or vehicle to infrastructure communication? I just want to clarify one thing. You can do vehicle to vehicle, but it is a little bit tricky. Currently, it is vehicle to infrastructure really, because these mobile networks, they don't have public IP addresses most of the time, so you need to punch a hole and you need to kind of do something special so that the nodes communicate to each other. Normally, we basically communicate from node to outside internet wherever we have a public IP. So that might not be the case for vehicle to vehicle, so you need to be aware of this. Some operators have public IPs, but it's probably not a good idea anyways. Just a few in our coverage in terms of operators. But it is vehicle to infrastructure, and if you want to do vehicle to vehicle, you need to work on it. Okay. Yes? Shall we see it in action?
Yes.
Hoping the Murphy is not around? Let's go. You want this?
No, the HDMI I would like.
I meant this for
the
presentation.
presenter.
Yeah, problem. Okay. HDMI is here. Just leave it here.
Yeah, sure. Okay, so Özgü talked about the scheduler and some of the experiments. So now we'll have a walkthrough demonstration of what you will be doing basically in the afternoon, or in 1 hour at least, not in the afternoon. And also some details how you can build your own container, even though that we may not get that far in the lab session. So I'm Stefan Alfredsson. I'm a lecturer and researcher at Karlstad University in Sweden. And these slides are on slideshare.net/Stefan Alfredsson 2. So there are some links embedded here, so if you go there you can find these more easily than typing them off the presentation. So what we'll look at is the kind of top-down approach to these experiments. So we'll look at just how do we schedule experiments, and we use that experiment as a service. So this means that
we already have a built Docker container, so you just need to know the name of the container and the parameterization, and then you can schedule it on a node, run it, and you will get some results, some experiment output, and we'll look at how you can download that. Özgü showed the download link, so we'll see what actually ends up there and how you can process it. And you can take one of these experiment as a service containers. They are on GitHub, and we can customize those. We can build our own container, push it to a repository, and then schedule it on some testing nodes also, if you are familiar with the Docker and Linux and so on. So that's also quite easy to do. But we'll start with the experiment scheduling. So we need to know a few things. So you need a name for your experiment, and this is a free-form name. You can name it whatever, test 1 or web experiment. Then you need a container to run, and in this case we'll have our web downloader, which is basically a container that is launching a Firefox instance and loads a number of URLs that you put in a parameter, and then it produces HTTP archive files. So you can see at the page load time, you can see the objects loaded and the sizes and so on, and then you can do some processing of that. You can submit some parameters, so they are in a JSON format, so it's key value basically. This is dependent on the container, so the parameters are not the same for each container. So depending on what you're doing, if you're doing a web download, you would like to enter the URLs. If you're doing some throughput measurements, maybe you would like to put in the responder host or the amount of data that you want to download or upload. And then you need to choose which nodes that you want to run this on. For your lab session, each group will have a defined node that you will run on, but there are some other properties that you can choose that you showed, and we'll also look at the live interface, how you can choose that. Okay, so in the slides I have some screenshot. Okay, so someone wants to so this site is, you see the URL scheduler MONROE system EU. To access this site you need a certificate, so you cannot go there at the moment, but Özgü will distribute this SSL client certificates for you to be able to access this site shortly. So this is the scheduler page. To submit an experiment, you would go to this tab new. You would name the experiment Web 4, for example. Docker MONROE system EU MONROE web/image. So this is the Docker image that we'll be using, and then we'll have the URL that we load. So we have KOSC, which is my university page, and we can have more URLs here, so we can just put in more if we would like. And so on. If you don't provide any parameters here, it will load some 100 URLs from Facebook and CNN and YouTube and so on.
So don't do that.
Don't do that. So then we need to choose which node or how many nodes we want to run this on. So now we'll just do it on one node. We have an experiment duration, so at tops we'll allow this experiment to run for 300 seconds. So please leave this by default. So if you change this maybe to 1 hour, then this node will be allocated for 1 hour, even if your experiment is much shorter. And for the test that you will be doing, this is more than sufficient. So how do we find a node to execute on? So here we have some node filter, so we can choose nodes in Norway that are deployed or in testing mode. So you didn't mention the difference between those two.
I think so. No, I did.
You did? Okay,
Yes.
so maybe I didn't. And then we have the different node modules, and we can choose how many interfaces we would like. And from this automatic selection, the scheduler will automatically pick one suitable node depending on this selection. I also think it considers the remaining quota of nodes, right? So to even out the quota usage. You can also see which nodes that are available. We have a resources tab here. And here you can filter. So if you don't filter, here we see all the nodes that we have deployed. So you see there are quite many. Do you know, Özgü, how many we are at the moment?
I mean, we installed more than 500,
Yeah.
but currently maybe 150 plus are operational on the new system, and we have maybe some on the old system.
Mhm. So for example, we have node 360, this is active, it's deployed, so which means that it's in its final configuration, and we can run deployed containers on that. It's in Norway, we have some host name, it's this APU type, we can look at the visualizer, and we see that it has a Telenor subscription, and we have used, or we have 46 gigabytes left, yeah. Out of a total, so each month we reset it to 50, or the operator resets the counters. We also have some other nodes, so here we have Telia Mobile with 200 gigabytes, together with ICE, unlimited data, and so on. So from this list, I mean, if you need some specific requirements of a specific location, you can choose an individual node. So we'll put it there. We'll run this on node 360. And we can choose the time when we want to run this experiment. Now we would like to run this as soon as possible. We check that it's available. So it could be that this node is occupied, that it's doing some experiment, or that it has some experiment scheduled for the time slot that we will be having. For the nodes that you will use in the lab session, we have made sure that they are not scheduled for the next hours. So we request this scheduling slot. And we could not submit it. Maybe
It was, just do it again.
yeah,
We
so
waited, so
need
we
to be
just
quick.
used
So,
the spell, yes.
so as soon as possible, request the slot
Yeah.
and submit.
Okay. Here's the Murphy.
Oh, okay. So we'll have another, maybe, do you know, 400?
I can check. Use, for example, 402. And if not, just show the results, so we can have a look.
So we were able to submit this experiment. So now it's in the scheduling system. In the status tab, we are now able to see this Web 4. It will start 11:01. So in half an hour.
Yeah, it's
So since this was scheduled as soon as possible, it could have been some other experiment that was scheduled before this. So then it just picked the time. But
Yeah.
I have some other output that we can look at. So then it will progress through some different statuses. So the experiment is defined, and it will be deployed, which is actually when the container is copied onto the node, and then it will be started, and then it will hopefully finish. And when the container is finished, it will say that, okay, so this is the schedule ID, so each run has an individual schedule to identify it, node 360, time of execution, and then we have the output of this experiment. So this is where you download the actual results. So you go here, you can have, for example, the container log. And this is basically the standard output of the container or the experiment script. So if you have some debug printouts, just go there and have a look. These two are the HAR file from Firefox, or filtered HAR web archive files. So this is JSON files, so this is unformatted, so it's a bit hard to read, but you can see that you have, for example, the URL, you have some timing, you have an object size, 41 kilobytes. You have the total page size, so this is around 4.8 megabytes, and I think you have so you have some ping values, and you have the web load time, so in milliseconds. So it took 16 seconds, 16.1 seconds to load this page. And then you can use your favorite tools to process this. If you use Python or C or C++ or C# or MATLAB or whatever. And I mean, this JSON format is supported in most languages for processing too. So you need to look at the keys and the values in here, and then extract the ones that you want to use. So let's see, where are we?
I just want to highlight something. Maybe if you go to the new part, new experiment, and if you go down. So when you're scheduling an experiment, if you basically have a different time here, for example, it just takes this as an initial time. So if you say, I would like to start tomorrow, and then give me as soon as possible after this time, so that will basically schedule based on this. So you need to get it like now, so you just immediately want to schedule it. I think that was what went wrong. And then you just basically can choose as soon as possible, and then it will just give you the next part. We can check it. So every group has a node, and we will be working with you, try to get your initial run successful. Then you can start more runs and try to collect a certain data set. But we will be with you, walking you through it. Yes.
So that was basically how you run an experiment as a service. You get the output files, and then you need to process these in some way. And if you want to change some experiment or develop your own, we have all the experiments on our GitHub page. So here we have, for example, headless browsing, hello world, HTTP download, some Paris traceroute, ping, preplay, RMBT for throughput measurements. We have a template container, we have traceroute container, and bandwidth estimation. And all of these are based on base containers. You had a question what software is included. And if you go here, you can see that we have the MONROE-based Docker file, which is the definition to build this Docker container, and here we have installation of the base software that we think that most people are needing. So we have various Python, T#, traceroute, fping, smokeping, nmap, flent, netverify, perf, mgen, dtg, oml, tcpdump, rsync, curl, wget, and all the things that you would expect when you're doing some experiments. Then if you have your own container, you may want to add some software to it. So then you would base the container with this directive from Monroe base. So then you will get all the software that is already in the base container, and then you will install whatever you are needing extra. So here there is a git clone of this RMBT client, and it's built and installed, and then clean up after yourself to make the container smaller. And then basically you specify that you should run this Python script for the experiment. So that is how you make a custom container, or that you can add software, and you can have all the apt-get install commands. You can build software and do whatever to make the container the way you want. So how are we time-wise? Should I?
I think maybe we stop here.
Should we stop here?
We take the rest in the lab session shortly, and then when I distribute all the services and so forth.
Yeah, so if someone would like to see the build of the Hello World container, we can take that in the lab session. But basically you need to install the Docker machine on your computer. You would clone this repository, run the build, push it to a Docker Hub account, customize the scripts, and then schedule it on a testing node. It's also possible to do some interactive SSH. So this is a bit more advanced usage, but you can actually log into the container to do some ifconfig or testing interactively. Okay. So do we have some questions, or should we break for the poster?
I would say let's have a break, and then we will interact a lot during the lab session in case. Yeah. It's a poster session.
Yeah, no.
All the posters are up.
You should have received this mail with the indication of which poster should be displayed now. So please approach the boards, which are by the table. Okay, copy the table by the link.
I will just run it. Which one you tried?